Hello and greetings. This is Dr. V.C. Sontake and I am the course faculty for the course Energy Conversion 3. In this video lecture, I am going to discuss about the atmospheric jet engines, also called as air breathing engines. So, objective of this video lecture is to explain construction and working principle of turbofan. In the previous lecture, I have discussed about the turbojet engine. Now, depending upon some of the modifications carried out in the turbojet engine to make it more versatile, there are two variants of turbojet engine. Turbojet with afterburner and turbofan. The construction and working principle of turbojet with afterburner I have already discussed in great detail. So let us discuss the turbofan engine. Turbofan engine is also known as fan jet. So let us discuss the construction and working principle. The construction of turbofan engine is as shown in figure. It consists of following components: diffuser, a large diameter fan, duct, it is also called as cowl, low pressure compressor stages, high pressure compressor stages, then low pressure shaft, high pressure shaft shown in purple color, high pressure turbine stage and low pressure turbine stage, then propelling nozzle or exhaust nozzle, then turbine exhaust, its mass flow rate is represented by m.h, and fan exhaust having the mass flow rate m.c, and when these two both exhausts are combined coming out from the turbine in the form of mixed stream, their mass flow rate is represented by m dot. So turbofan is also similar in construction with turbojet engine, with following modifications are incorporated in the turbofan engine. First is a large diameter fan is introduced just after the diffuser, and a ducting is provided surrounding all the basic components of turbojet engine. And in case of turbofan engine, compressor stages are divided in low pressure and high pressure stages. Similarly, turbine stages are also divided in low pressure and high pressure stages. Here, high pressure turbine stage represented in purple color will drive the high pressure compressor stages, and low pressure turbine stages shown in green color with the help of low pressure shaft will drive the low pressure compressor stages. So if you remove the cowling and the fan, the turbofan will become turbojet engine. Combustion chamber is also there as usual. Now, how does it work? So, the working of turbofan engine is somewhat different from turbojet engine. Incoming air is allowed to enter into the turbofan engine, where the incoming air is first enters into the diffuser. Diffuser increases the pressure energy of the atmospheric air at the expense of its kinetic energy and slightly increases the pressure of atmospheric air. This process is called as ram compression. Now, the atmospheric air with increased pressure is allowed to pass through the large diameter fan. This large diameter fan makes most of the air, cold air or atmospheric air, to flow through this ducting or cowling where this cold air is flowing and finally comes out of the turbofan at very high velocity and gives rise to the thrust. Only 10 to 25% of this atmospheric air which has entered into the diffuser and through large diameter fan is allowed to flow through the low pressure and high compressor stages where its pressure is further reduced, further increased, to a higher level. Then they are passed to the combustion chamber where fuel is added and combustion takes place and pressure is increased as well as temperature is increased. Pressure is always increased by compression in the compressor stages, and in the combustion chamber the temperature of the exhaust gases is further increased. These high pressure and high temperature gases are allowed to expand in the turbine, where this turbine produces required work output to drive the compressors. High pressure and low pressure turbine stages will drive high pressure and low pressure compressor stages respectively. Now, after passing through the turbine stages, high pressure and high temperature gases will now expand in the propelling nozzle and will come out in the form of jet at very high velocity and will further produce thrust. So in case of turbofan engine, thrust is having two components. Thrust generated by the cold air flowing through the duct and coming out from the turbofan engine with very large volume flow rate and high velocity, and the second component is thrust produced by the high temperature and high pressure gases coming out from the nozzle with low volume flow rate and high velocity. At the exit of the turbofan, turbine exhaust and fan exhaust are mixed and they come in the form of mixed stream having mass flow rate m dot. So this way turbofan engine generates thrust. So the point worth remembering in case of turbofan engine is that turbofan engine generates 90% of its thrust from the expansion of cold air stream and only 10% of thrust is produced by hot air stream expanded in the propelling nozzle. So let us further elaborate the working of turbofan engine. The turbofan engine is a modified version of turbojet engine with an aim to reduce jet noise and to improve propulsive efficiency. A large fan driven by the LP turbine stage forces a considerable amount of air having mass flow rate m dot c through a duct called as cowl surrounding the engine. Only a part of the air having mass flow rate m dot h from the fan is passed to the conventional turbojet engine. The fan air exhaust leaves the duct at a higher velocity and high volume flow rate, enhancing the total thrust of the engine significantly and thrust produced by this cold air is almost 90% of the total thrust of the turbofan engine. The hot gases leaving the last turbine stage then expands in the propelling nozzle or main exhaust nozzle and develop thrust at a high velocity and relatively low volume flow rate. And the thrust produced by these hot gases is 10% of the total thrust produced by the turbofan engine. In turbofan, the thrust is made up of two components: the cold air stream flowing in the cowl or duct, or also called as fan thrust, and hot gas stream thrust through the propelling nozzle. In turbofan engine, for the same power, a large volume of slow moving air produces more thrust than a small volume of fast moving gas. Please remember this thing. Large volume of slow moving air flowing through the cowl or duct produces more thrust than a small volume of fast moving gases coming out from the nozzle. And their ratio is 90:10 almost. In a turbofan engine, the high speed exhaust gases are mixed with the lower speed air at the exit of the turbofan engine, and this results in a considerable reduction in noise level. And this reduction in noise level is almost 20% lesser than that of turbojet engine. So this is very important aspect of turbofan engine or modification done in turbofan engine to reduce the noise level. Since a large part of the total thrust is obtained by the cold air jet at a low velocity, the propulsive efficiency of turbofan engine is high at subsonic flight Mach number. And the turbofan engine deserves most of the credit for the success of jumbo jet that weigh almost 4 lakh kg and are capable of carrying over 400 passengers for up to a distance of 10,000 km at a speed of 950 km per hour with less fuel per passenger per mile. So turbofan engines are used in turbojet engine, and because of their versatility of producing thrust with reduced noise level, jumbo jet could be made. And you can see the technical specifications of jumbo jet. It weighs 4 lakh kg. It can carry 400 passengers at the speed of 950 km per hour, and that too with the very good efficiency, fuel efficiency. So that is all made possible because of the turbofan engine. Now, thermodynamic analysis of turbofan engine. The total amount of air or the total mass flow rate of air entering the fan and finally leaving the turbofan engine is m dot is equal to m dot c plus m dot h, where m dot c is the mass flow rate of cold air flowing through the cowl and m dot h is the mass flow rate of air and gas flowing through compressor, combustion, turbine, and finally flowing in the form of gas through the propelling nozzle. The bypass ratio is defined as the ratio of the mass flow rate through the bypass duct, that is fanjet or cold air stream, to the hot gas stream. So bypass ratio is very important ratio for the turbofan engine, and mathematically bypass ratio represented by capital B is the ratio of m dot c to the m dot h. Let's say this is equation number 1 and this is equation number 2. If we solve equation 1 and 2 simultaneously, it will give me m dot h is equal to m dot over b plus 1 and m dot c is equal to m dot b over b plus 1. So with the help of these two equations, I can calculate the mass flow rate of air flowing through the cowl or through the conventional turbojet engine in case of turbofan engine. The modern turbofan engine uses a bypass ratio of 8 or more. Generally, the range of bypass ratio is from 0.3 to 8 or more. Now, applications of turbofan engine, they are used in modern passenger planes like jumbo jet and large passenger or cargo planes. So, learning outcome of this video, at the end of the lecture, learner will be able to explain the construction and working of turbofan engine. Learner will also be able to explain what are the modifications carried out in turbofan engine over turbojet engine. In next lecture, I will be discussing the construction and working of turboprop engine. So with this, I come to an end of this video lecture. Thank you for your passionate listening and kind attention. Happy learning.